Alright, so in this video we are going to finish what we started yesterday and talk about lesson 3.4. So yesterday in class we started by summarizing where we've been so far. We've talked in 3.1 about measures of center, 3.2 measures of variation, Chebyshev's rule and the empirical rule was 3.3, and now we're on to 3.4, which is the 5-number summary and box plots. So they go hand in hand. We need the 5-number summary in order to create a box plot. And one of the important things about this lesson is these things we're going to be talking about today are resistant, which means they are not going to be affected by outliers. So if we have one really big or one really small number, it's not going to pull the 5-number summary way to the right or way to the left, which is a good thing, and one of the reasons why we want to use box plots in the 5-number summary to describe data that we collect. So let's continue. One of the things we said that we're going to talk more about later is we can talk about percentiles, which is if we say something is in the 15th percentile, that means it's better than 15% of the data that we collected or the observations that we have. We could say talk about deciles, where we divide them into groups of 10, or quintiles, where we divide them into groups of 5. But we're going to focus a lot on quartiles, where we divide the data into groups of 4 equal parts as far as the number of data points. And so you can see here's a uniform data where the 25% is all kind of uniform, and the space between in the 3rd quartile, which is from these two areas, is the same as the 4th quartile, and so on. That's different than in other places, like you can see here where it's skewed to the right. Here we have the 1st quartile, we have the 2nd quartile, we have the 3rd quartile here, and then we have here the 4th quartile, but you can see the distance for the 4th quartile goes from here to here. That distance is a lot more than the distance of the 2nd quartile, which only goes from here to here. And so it could be spaced out differently depending on what the data looks like and how it's spread. So one of the things we're going to do is look for the Q1, the Q2, and the Q3 values. So here we have these things are designated Q1, Q2, and Q3. The 1st quartile is the 25th percentile. The 2nd quartile, we've called this the median before. So it's the exact same thing as the median, but it's also the 2nd quartile, or Q2. And then the 3rd quartile is Q3. They have a list here of steps that you can take in order to find the quartiles, but we're actually going to do that together by looking at your test statistics on our last test. And so we're going to take a look at these numbers, but I'm going to have to get out of this mode here for a second and pull up my calculator so that we can do this together with our calculators. So here's what I've already done. I've already taken these numbers and put them into my list. So if I go to edit and edit, here's my list. These are our actual test results. So we had scores from 43% all the way up to 98%. And there's 15 of those numbers. So what we could do is we could find cross off the highest numbers, like the top 5 numbers would be 1, 2, 3, 4, 5. And the bottom 5 numbers, 1, 2, 3, 4, 5. Now my pen's not working, I don't think, here, so I can't cross them off. But if I crossed off my bottom 1, 2, 3, or my top 1, 2, 3, 4, 5, 6, 7, and my bottom 1, 2, 3, 4, 5, 6, 7, you can see that the middle number would be 80. That would be my median score. Then I would take that 80 and I would include that in my bottom half and my top half, and find the median of the bottom half and the median of the top half. All of this can be done by hand, but I wanted to show you how it could be done with our calculator as well. I'm going to go back to the Stat button then, and I'm going to move over to Calculate, and I'm going to do one variable stats, which is what we've done before. If you remember right, when we've done this before, here's our mean. So our average on our test was a 74.9%. Standard deviation was 18.8. So that's kind of a big standard deviation. Our scores were kind of all over the place. If I scroll down, though, you can see there's more numbers going down here. I wonder if I did that right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I made a mistake here because I only have 14 numbers. So I'm going to have to go back and see which one I did not include. So we have 43, we have 46 twice, then we have a 63, a 65. I need another 65 in there, don't I? So what I'm going to do is go down to the bottom, and I'm going to add a 65 so that we do this right. So here is 65. And now I'm going to go back to stat and calculate, and one variable stats. Let's see how this changes. So now that second 65 brought our average down to 74.2%. Our standard deviation is still 18.3. But if I scroll down, now I'm going to get the quartiles. Here's the median. So the median value is 80. That's the second quartile. And then the Q1 is 63 and the Q3 is 90. So I want to show you how we can do that not only with our calculator, but also by hand. Notice the min and the max. We're going to talk about this later, but this is our 5-number summary. The min, the Q1, the Q2, the Q3, and the max. And so let's go back to the PowerPoint itself, and let me just talk about how to do this by hand. So now I'm going to use my pen and actually cross these things off. So the bottom 1, 2, 3, 4, 5, 6, 7 numbers, and then we have the top 1, 2, 3, 4, 5, 6, 7 numbers, and what's left is this 80 in the middle. That's my median score. So I would say Q2 is 80. But then I'm going to take all of these numbers and include the 80. Include the 80 in my bottom half. And so then I'm going to cross off the 1, 2, 3 lowest and the 1, 2, 3 highest. And it looks like it's right between 65 and 63. I don't know if this is the way the calculator figured this or not, but if it isn't, I would accept both of them. If I average those two scores together, add them up and divide by 2, that means my Q1 value is 64. Then I'm going to take my bottom or my top half, and I'm going to cross off the bottom 1, 2, 3 and my top 1, 2, 3, and it looks like it's right between 88 and 90, and if I average those, it's 89. I think it's actually different. Like the calculator must calculate that differently than what I want you to if we did it by hand, but I would accept either one of those. I would say our Q2 value is 80, our Q1 value is 64, and our Q3 value is 89. I think they actually did not count the middle value, but we're going to count it. If we have a middle number, we're going to count it in both the bottom half and the top half. You can see the textbook that we use counts it, but the calculator that we use must not count that middle number. And so those are the Q1, Q2, and Q3 values. And so another thing that we're going to look at is the interquartile range. So that's simply the difference between the Q1 value and the Q3 value. And so we're going to make a box plot here in a minute with the values that we just found with that information, and calculate what the interquartile range is, and talk about where you can use it and how you can use it to interpret data. But there is a range. The range is the maximum minus the minimum, but the interquartile range is the difference between the Q3 and the Q1 value. So that's a different kind of range. It's not the highest and the lowest, but it's the middle of the highest numbers and the middle of the lowest numbers, what that range is, which is another measure of variance. And so here's the 5-number summary. We talked about this a little bit. The 5-number summary includes these 5 numbers. We have the minimum, the Q1, the Q2, the Q3 value, and the maximum. And those kind of give us a really good, this is all that we really need in order to make a box plot of information. And so let's talk about, let's do the box plot, I guess, first. I think I was planning on doing this later. It's to construct a box plot. It has these different steps, but we're going to go back and actually construct a box plot of this data. And so we want to first make a scale. I'm kind of doing this Hopefully this looks okay. But I'm going to make a scale where maybe this is 40, here's 50, here's 60. I want an even scale. Here's 70, here's 80, bear with me here. Here's 90, and here's 100. And I'm going to first make a line where my Q2 value is, or my median. That's the 80. And so 80 is right here. So that's my middle number, my median score. Then if I were to take the median of my lower half, that's the 64, that's the Q1 value. 40, 50, 60, 64 is going to be about here. And then I'm going to take the median of my top half, which is 89. 89 is about here. And that creates my box. Okay, so there's my box in a box and whisker plot. These should be erased here, but you have the idea. There's my box. Then I'm going to put another line at 43, which is right about here, and another line at my top number, which is 98, which is about right here. And I'm going to connect those lines to my box. Now, obviously, this doesn't look very good because it's sloppily done, but you can see here's my box plot. And so what it means is that you can see from this point to this point is a pretty wide range of test scores. The interquartile range goes from my Q1 to my Q3 value. That is 89 minus 64, which is, let's see, that would be 25. So my interquartile range is 25. My actual range, which goes from my highest to my lowest, that's 98 minus 43, which is 55. So that's a pretty wide range of test scores, but the interquartile range tells me that the middle half of the students scored between a 64 and an 89, which is a range of 25. That is a pretty big interquartile range. And so you can see the 15 of us who took that test last week, we just kind of, our scores are kind of all over the place. That makes it more difficult to teach because we have people who probably should go back and relearn some things, and we have some people that really understand it and would probably be bored if we went back and relearned some things. So let's go, oops, I'm going backwards. Let's go back here. So we have the 5-number summary, and then we have what we're going to talk about, how to determine outliers. So I don't think we're going to have any outliers in the data that we just talked about, but here's how we determine what the outlier is. We're going to take our Q1 value, which I think was 64, and if we subtract 1.5 times our interquartile range, which is 25, what we're going to get if we do that, 1.5 times 25 is 37.5, and if I add 64 plus 37.5, I'm going to try to do this in my head, that's going to be 102 point something maybe. If I had a number, no, if I subtract it, 64 minus 37.5 is going to be close in the 30s or maybe even in the 20s. That's called a lower limit or a lower fence. Anything lower than that would be technically considered an outlier. And so we don't have any numbers. Our lowest score was a 43%. That's not an outlier. It would have to be, it's not this, it would have to be below a 30, whatever 64 minus 37.5 is. To get an upper limit, we're going to take our Q3 value. Our Q3 value was 89, and we're going to add 1.5 times our interquartile range. So 1.5 times 25 is 37.5. We would have to take 89 plus 37.5, which is well above 100%. And that would be our upper fence, which means anything above that distance would be considered an outlier as well. And so that's how we find outliers. And I'm going to see if I can kind of rush through this. We've already done the box plot. Here's box plots of data that's already been collected. I want you to take a look at this. If you have an outlier, you denote the outlier with a point, and it does not include, it's not included in the actual whisker part of the box plot. Okay? So that's what we're doing here. Here's just 2 box plots put together to compare some things. That's assignment number 4. you can now go back and begin 3.4.